Okay, now in this particular video, we are going to be treating the concepts concerning lifts or elevator. But sometimes questions on this come out, especially in your screening and the JAMB. They always ask you questions concerning lift movement. So we have 4 concepts. So please take note of this, and I don't want any confusion here. So we are going to take time to clarify you. After clarifying, you'll be happy what you are going to see in this particular video. Now, the first concept is when the lift. So whenever a lift is moving upward, if you enter a lift. So what they are actually trying to see in this particular question or about a lift here is, if you enter a lift, you have a particular mass before entering a lift. Now, once you enter a lift now, if the lift is going up, what happens to the total weight? Or you can say the total force. So that is the question now. So remember, you have the weight of the lift itself and your weight. So what now happens to the total force there? So the apparent weight, that is the total force acting when it is going up. So that is what we have here. So F here stands for the resultant force. What is the apparent? Remember, weight is a type of force. So what is the apparent weight considering your original weight and the weight of the lift? So what is the outcome, the resultant? So when the lift moves up, the apparent weight, which is also the total force here, will be the reading on the lift, or you can call it the reaction, minus your original weight. So you have the reading minus your original weight. That will give you the apparent weight or the total force acting on that particular lift. So you can get the reading of on the machine, the lift. You subtract it away from your own weight. That gives you, that is when it is moving upward. Remember, when moving upward, acceleration due to gravity is occurring. Now, what if you are coming down? You enter a lift and you are coming down. So the reverse is the case. In that case now, since you are coming down and the acceleration coming down, acceleration due to gravity is favoring the movement. Therefore, it will add to your original weight. So the original weight will be greater than the reading on the machine. Are you getting the point? So our resultant force becomes the original weight minus the reading on the machine. That is the reaction on the machine. So you get the resultant force, which is the apparent weight, the total weight inside the lift. Now here, when the lift is at rest, this time around, the lift is not moving. So once the lift is not moving, it's at rest. That means that what we don't have here is what do you call it? We don't have acceleration. Normal linear acceleration does not occur here. So in that case now, the same thing happens when you have a constant speed. If the lift is moving with a constant speed, you are not altering the speed. So whether the lift is moving constant speed, always watch your question, constant speed or at rest, the reading on the lift will always be equal to your weight. No movement, you just enter the lift, inside the lift. So your common sense should tell you that a lift that is not moving, nothing is happening there. So the lift takes the weight of the body. So the reading on the lift is equal to the weight of the body. The same thing goes with constant speed. Now finally, when the lift is falling freely, just falling freely, in that case you don't need to solve anything. The reading on the lift is equal to 0. So this is a very simple concept. We are going to solve a question to use to illustrate how to apply this particular formula. In this question, I will elaborate more on this. This is the shortened version of it. So let's quickly solve a question. Okay, so we have a question on the board. Now we're going to use this question to illustrate what we just finished, the concept, each of them. Now, the question says, a girl whose mass is 55 kg stands on a spring weighing machine inside a lift. So we are discussing lifts now. If its acceleration is 2 meters per second square, what will be the reading on the machine? Remember, I told the reading on the machine is equal to the reaction the machine is giving. So what is the reading on the machine, which is the reading on the spring of the machine, when the lift starts to ascend? So once you enter and the lift starts to ascend, and we are told that the acceleration is this. So B says the lift starts to descend. So it's not coming down or from up to down. So C says the lift moves up and down with a constant velocity. With a constant velocity. D says the lift is at rest. So let's quickly solve that. We have solution. Now for a question, the lift starts to ascend. First of all, let's write out our parameter. Our acceleration is 2 meters per second square, and we have our mass as 55 kg. Then the next thing we have is G in brackets. G is given to us as 10 meters per second square. Okay, so a question says the reading on the machine. The reading on the machine, be very careful. They're not asking us the apparent weight, no, or the force, total force, no. What they're asking us is the reading on the machine. That is the reaction of the machine. So remember, but we know that the apparent weight, the total force, when it is ascending, so when it is ascending, the reading of the machine seems to be bigger than the weight. So we have R minus weight. Now what we are looking for is the reading here, R. So if you make R the subject, R becomes, this is negative here, crossing the equality sign changes to positive. So this gives us F plus W. So always understand. So this is the reading on the machine. That's the reaction the machine gives you, the lift. While this is the total force. So what we have now is, this is mass times acceleration. We know that. Plus, this is mass times acceleration due to gravity. So what is common is M into A plus G. So M is 55. A is 2. Plus, this is 10. So we have 55 times 12. It's 660 Newton. 616 Newton. Remember, the reading on your spiral spring is a force, so it's in Newton. So 660 Newton. So always watch, be very careful, know what they're asking you. But had even they say we should calculate the apparent weight. The apparent weight, you use this formula. In that case, you'll be given the reading on the machine. But this time around, we know this already, so we are asked to calculate this. So this is how you solve it. So we go over to question B. So B part of the question, when the lift is descending, coming down, in that case, remember, we said F. Now, the weight will be bigger than the reading on the spring. The weight will be bigger than that. So if we make the reaction, the reading on the spring, the subject, remember it's positive, sorry, negative, crossing changes to positive. So we have R is equal to W minus F. This is positive here, crossing over changes to negative. So in that case, we have mg minus ma. So m into this minus this. So m is still 55. This is 10 minus 2. So a is 2, g is 10. So that will give us 55 times 8 is 440 Newton. So as you can see, that when it is coming down, the weight seems to be what? Smaller. Seems to be smaller than when it is going up. Because acceleration due to gravity is favoring any lift that is coming down. So it makes the weight lesser than when it is working against gravity. So we have C part of the question. Now C says the lift moves up and down with a constant velocity. Okay, let's see what that is. So we develop the concept. We say anytime the lift is moving up or down with a constant speed, or it is at rest with a constant speed or at rest, that what we simply have is that the reading is equal to the weight. It takes the weight. It's not moving. So once you just enter the lift, it takes your weight. If you check, it takes your weight. It's not moving. But once it starts moving, everything changes. It alters. So our reading on the spring is simply mg. So which is mass, which is 55 times 10. So this gives us 550 Newton. It's as easy as that. So this gives us 550 Newton. Same goes here when the lift is at rest. When the lift is at rest, the same thing. When it is moving with a constant speed, you don't alter the speed. Constant speed, it is still the same thing. So I'll simply D is the same thing as what? Wmg. So what you have here is 550 Newton. So always understand your question very well. Constant speed is the same way of solving when the lift is at rest. Okay, so with this, if you have any questions concerning this, drop it in the comment section. Now, for this, any other question you have, drop it in the comment section. For more questions, like I always tell you, visit the exercise section and the past question section. You are going to come across a lot of questions concerning this.